Okay. No one is in as yet. X squared plus 8x plus 15. So we are going to have in a minute all the trinomials that should have been factorized up to the time. We're going to place them on the board and we are going to factorize every single one of them. Today is our problem solving class. As it is every Sunday, we have what we call tutorial. And in this class, we solve problems. That means we apply. Yes, that means we apply what we learn. So this is no doubt an application class. Yes, it is an application class. We apply what we learn. So we have instructional classes. In an instructional class, what do you do? What do we do in an instructional class? We explain concepts. We develop concepts. Everything that has to do with principle, that is what is done in an instructional class. So we learn the concepts. Of course, we're going to learn through activities because we have activities in those classes also. And we have problems to solve. We learn by example, we learn by precept, and we learn by practice, we learn by example also. However, this class is a class that is chiefly for problem solving. 7. A squared minus 2a minus 48. Surely, in a tutorial class, you can learn. You can learn the concepts. So, you're not at a loss if you did not attend the pertinent instructional class. On a few occasions, yes, on a few occasions, I write what? That should be a plus. An incorrect sign, and of course, just an incorrect sign has the potential to throw everything out of whack, to throw it all out. This one can be seen in one above it. I think that you'll be able to see that one. The light is right there. So, number 10, don't put one beside number 10. Or, let's see if we can get a few more. It doesn't matter because we'll have to start over because we have 20 of them. So put one beside number 11. This is number 14. All right, so nice. All right. So here we are. Let's see. Okay, that's nice. We're just in the nick of time. Yes, we are just in the nick of time. Excuse me. This will work. All right. Now, for those students who did not attend the pertinent instructional class, that should still not prevent you from being able to factorize, because it is based on a simple concept. The middle number is the sum, and the end number is the product. But it comes with a bit of sophistry because, not because, yes, it comes with a bit of sophistry because we have a nice mixture of signs to handle. All right, so since we're at the beginning, I'll just take the opportunity to say a warm welcome to everyone and a very good evening to everyone. And no doubt, you know that I'm generally very thankful to all for being here, because the intents and purposes of this class cannot be fulfilled if you are not here. And in mathematics, we study theory, and we study something known as what is sufficient, and of course, what is necessary. Yes, we say if it is sufficient, if it is necessary, it is necessary, but it's not sufficient. If it is necessary and sufficient. So we study those things. And it is also, yes, necessary for you to be here and take in an active part. And I see new followers of Richard James. Welcome. Thank you also for those who are sharing the live, some are liking the live, and so on. You know, at the end of the year, when I evaluate what we have done for the entire year and what we have achieved, the evaluation is going to be such that we consider it to be something that is going to be very helpful and supported, or something that is quite the opposite. So I think that we are on the right footing at the moment, and we'll just continue like that. And any move towards an improvement is always going to be welcome. Now, some of you are new, and we are factorizing trinomials. I am 100% sure that for some of the new individuals will still be able to factorize the trinomial. Now, earlier on, I emphasized and overemphasized how important it is for you to understand the manipulation of directed numbers. Here it is. This is a significant application of directed numbers. I think that this is one of the most critical, and this is one of the, of course, requiring critical thinking. And I think that this one is one of the greatest. Working with trinomials is among the greatest tests of how competent you are manipulating directed numbers. Nice. So let us look at the first one. In this case, we are factorizing x squared plus 8x plus 15. Of course, this is not the end of trinomials. We have two, what I would say, levels of trinomials. The one with the coefficient of the square term is 1. We just do that in one step. And of course, the other one can be done in one step, but we opt for the earlier stages to, of course, resolve the middle coefficient into its two components and factorize by grouping. And that is what we are going to do tomorrow. In that, we have, of course, your basic introduction. Then we have what? Large coefficients. Then we have the twisters, and that will be the end of it. Not the end of it in terms of what you will be seeing for trinomials, because by the time you are through with this algebra book, you'll be using trinomials maybe 2 more times. Yes, maybe another 2 times at least. So 2 or 3 more times you're going to be required to take a look at trinomials. And then you have functions. Of course, this is functions. You're going to have functions part 1 and 2, and you're going to see trinomials quite a bit. What did I do wrong? All right. I hope that I did nothing wrong. So let's go. let's factorize the first, how many will I say? Yes, the first 4. So we're going to have 5 fours, 20. So let us take these 4. Now, when all of the signs are positive, you know that this is your most basic factorization of a trinomial. So let's go. The two numbers, what two numbers do you know multiply to give 15, and when you add them, the result is 8? So the two numbers have a product of 15 and a sum of 8. I want to give you a shot at it first. Multiply to give a sum of 15. Sorry, multiply to give a product of 15. When you multiply them, the result is 15. When you add them, the result is 8. So we have a 5 and a 3. So all that you need here is x plus 5, x plus 3. What about this one? We have signs starting to play a very important role at the moment. So we have x squared minus 11x plus 24. So the product is 24 and the sum is negative 11, and you're going to give me the results with their signs, because if you give me the results with incorrect signs, then the entire thing is incorrect. Give me with correct sign. Let's go. Multiply to give a product of 24, and when we add them, we get negative 11. What are they? Negative 8, negative 3. Now, students, this is how you do it. When you look at the product, you have an early conclusion to arrive at. The early conclusion is whether they have the same sign or the signs are different. If the product is positive, as it is in this case, you know already that the numbers have the same sign. If the product is positive, they have the same sign. So you have that locked away already. You have gone through that door never to return. Then when you see the sum is negative. That tells you that the two numbers must be negative. Yes, first of all, you have to conclude the two numbers have the same sign because the product is positive. They must have the same sign. The sum is negative. That tells you that the two numbers are negative. So we are going to have here, and I'm sure, x minus 8, x minus 3, and no one will have any difficulty with that. That does not look like a 3. That looks more like a 3. Thanks. All right, so the next one. These numbers have a product of 24 and a sum of negative 8. What are those two numbers? A sum, let's say that again, a sum of positive 28 and a sum of negative 11. Of course, this one is analogous to that. Students, learn to solve by analogy. When you see a problem like this, and you have concluded on the signs, then you see one more like it, which is this, only the numbers are different, then you may use the similarity that exists between the two problems in solving this. And that is totally acceptable. Solve by analogy. Right. So 28 is equal to 7 times 4. And of course, if you add a negative 7 and a negative 4, you will get 28. Now, of course, you have other factors of 28. 28 times 1, 14 times 2. You have to choose the one with the sum that is going to give you negative 11. And this one, number 4, is a model problem. Yes. Number 4 is a model problem. Number 4 is a model problem. Why? Because the coefficient of the middle term is either a positive or a negative 1. Yes. And I see individuals supplying their answers right there. And I'm delighted to see so many correct answers. I need correct answers, students, because sometimes I'm wrong. I do not have a halo, and I do not have wings. I'm wrong sometimes. So I'm delighted to see the correct answers coming up. All right, so let's go. This one, y squared minus y minus 5. As I said before, that one is a model problem. It's a model problem because the coefficient of the middle term in that particular case is negative 1. And if it were a positive 1, it still would have been the model problem for the same reason. So before I take a go at it, I will want you to take a go at that one and see what you make of it. Let's go. I'm sure that the correct answer will be coming up in a few seconds. That's the confidence that I have in you all. And then I will explain whether you're right or wrong, why it is a model problem. Yes, why it's a model problem. Let's go. They multiply to give a negative 42. And when you add them, you get a negative 1, because the coefficient here is a negative 1. They multiply to give a negative 42, and when you add them, you get a negative 1. Let's see the answers first, before we dissect that one, because I'm going to dissect it nonetheless. A negative 7 and a positive 6. No, students, I'm going to dissect it. 1, the product is negative. The product is negative, and you know that for a negative product, one of the numbers must be positive and the next one must be negative. The two numbers must have different signs for the product to be negative. So as long as the product is negative, one is positive, the other is negative. You pass through that door never to return. So at the end of it, I don't want to see two negative numbers or two positive numbers, because you have already concluded that because the product is negative, that the answer is going to be such that we have a negative and a positive to multiply to give the negative. So we are sure that one is positive and the other is negative. Go back to your first rule of directed numbers. When you add numbers with different signs, the answer will take the same sign as the larger after you find the difference. So the answer will take the same sign as the larger. So because this one is negative, because the coefficient is negative, after you have concluded that they have different signs, you see that the sum is negative. That means the larger one has to be negative. So the larger one has to be negative. So I say a negative 6 and a positive 7. Keep presence of mind, students, because sometimes after you have concluded on the size of the numbers, then the sign of the numbers that you assign, because you already know, and so that is a gone conclusion that the numbers have different signs. And of course you have one with a negative 6 and a positive 7. So that's fine. Right, so yeah, that one is fine. But do not forget that when you're adding numbers with different signs, the answer takes the same sign as the larger. So the sum is negative. That means the larger one has to be negative. And here we have now this answer, a negative 1 and 42. Is the answer correct? Some will say that answer is miles away. No, it's not miles away. It's not right, but it's not too far away. Because one might choose a negative 1 with a 42 on the premise that we have a negative 1 right here. And that is without combining the numbers. And of course you need to combine the numbers. So that peak is not horrible by any stretch. Why do we still see the negative 6 and the positive 7? We should not see a negative 6 and a positive 7. Because we know that when we add numbers that have different signs, the answer takes the same sign as the larger one. That means the larger one, since they have different signs, the sum is negative. That means the larger one has to be negative. The larger one has to be negative. And this is what I say is a model problem. Why I say that it's a model problem? Because you need to know right off the bat, and I hope that we see more before we are through, that when there's a difference of 1, whether it be positive or negative, that the two numbers are consecutive numbers. Because I don't see another one, then I have to press hard on this one. Or maybe we'll see another one because we still have 5 more to go. So when we see the sum is either a positive 1 or a negative 1, we know that the two numbers are consecutive numbers, like a 6 and a 7, like a 5 and a 4, like a 3 and a 2, a 1 and a 2, like an 8 and a 9. The two numbers are consecutive, so much so that when you subtract one from the other, the result is 1. Just like 6 and 7 are consecutive. So when you subtract one from the other, the result is 1. So as soon as you see 1, when the difference or the middle coefficient is a positive 1 or a negative 1, of course, you would expect that the number here is negative, so that you can have the difference between the two of them. Because if the number here is not negative, you're not going to have a difference between the two numbers, because the two numbers will have the same sign. And when two numbers have the same sign, we add the values. So when you see a positive 1 here or a negative 1, as long as it can be factorized, you should expect that this number is negative, and you expect that the two numbers are consecutive, just like a 6 and a 7. Nice. So the correct answer was given earlier, and that is going to be what? X plus 6. I don't think it was given like that though. It was given in the other order, x minus 7. The x minus 7 came first, I think, but it doesn't matter. Of course, these two pairs of parentheses means that these two are being multiplied by each other, and you know that multiplication is commutative, meaning that the order in which we multiply numbers does not affect the result. All right, so you have a few seconds, and we'll take a look at 4 more. Lovely. And we are going to have some more. Four more. All right. This is your favorite. All of the coefficients are positive. One knock, and you throw that one over. You tell me why. You tell me why I use X for the answer when the question has Y inside there. You tell me. Can anybody tell me why I use X for the answers? Why and why are the Y values are there? Anybody prepared to answer why I use X for the values when Y there? Tell me why. Let me see who is thinking. Somebody please tell me why I have X here when Y's are there. Tell me. Students, all, this is a mathematics class. Use your brain. Tell me why. It's a human mistake. You think I have a halo or wing for me back? All you need to do is say, sir, you should have Y there, instead of asking a question like that. It's a normal human error. Oh, sir, you should have Y's there instead of X. Point it out. Let's go with this one. That one is nice. Two numbers to multiply to give 30, and when you add them, the result is 13. I saw that. I saw that one, leaving school from 1992, and never what? Noticed that. No, there are quite a few things that if you are going to notice, if you follow Richard James' Mathematics Resources. I've written a book by the name of Mathematics. And that one, you would really like to see that. But I'm going to be applying a lot of mathematics when I'm in my regular class. So I'm going to be using mathematics quite a bit. Let's go, students. 10-3. Yes, it's a regular 10-3 problem. Right, so that one is what? S plus 10. S plus 3. So that one, this one also has all positives, and because of the 33 here, the result for this one is easily attainable. Reason being, 33 does not have a lot of factors, like 30. Because for 30 you have 1, 2, 3, 5, 6, 10, 15, and 30. So for this one, you have a lot to choose from, while this one is quite narrow. So this one, you shouldn't have any difficulty with that. That one is simple, 11-3, and all the signs are positive, so no problem. B plus 11, B plus 3. Now here's a beautiful one for you. Very interesting. Number 7, a squared minus 2a minus 48. The product is negative 48. The sum is negative 2. I would like to hear what you have to say about this one. Positive 6 and negative 8. All right. So, if you wish, you could think of it like this. But if you have your special way of thinking about it, then go straight ahead. Right? Because I am not one to say that you have to do it like this. You don't even have to use a method that I use. You can make up your own method on your own. That's, as long as it is mathematically legitimate, then that's going to be acceptable. Now, negative 48 tells us that the numbers have two different signs. So when I think about the different signs, I think that we are going to have a difference. So instead of, because the signs are different, instead of the sum that results in accumulation, the sum is going to result in a difference. So it's going to be a difference between the two numbers. So which two numbers multiply to give 48 and the difference between them is 2? The numbers multiply to give 48. The sign is different. Sorry, the sign is negative. Because the sign is negative, then the two numbers have different signs. We are going to find the difference between the two numbers. Which two numbers multiply to give 48 and the difference between them is 2? So your correct answer is 6 and 8. Do not forget that the answer will take the same sign, which is the sum. The answer of the sum will take the same sign as the larger one. Therefore, it has to be the larger one that is negative. Nice. Here, one of your problem students, if you practice enough, as soon as you see a trinomial, you figure it out like in an instant. Because you know that this is a model problem. We have more model problems. We have at least another one for you to take a look at. This is a model problem where the difference between them is 1. So that's 2 consecutive numbers. And for this one, you can come to your conclusion early because it's a problem that is analogous to this one and it's analogous to this one. So you have solved 2 problems to which this one is analogous. This one is analogous to these 2. So you can just use that fact to assist you in solving this problem. Solving by analogy is okay, students. You don't have to invent the wheel every single time you solve a problem. Let's go. They have a sum of negative 17, but they have a product of 60. This is a twister. I'm going to put that in the twisters on Monday, which is tomorrow. I'm going to put that in the twisters. Let's go. I'm looking for answers. They have a product of 60 and a sum of negative 17. The only assistance that I can give you now is to put the x's in. Negative 5, negative 12. 5, 12, 60. Of course, the product is positive, telling you that the two numbers must have the same sign. Because the middle is negative, it tells you that the two numbers are negative. So the positive product tells you that the two numbers have the same sign. Then the negative sum tells you that the two of them are negative. 5, 12, 60. And when you add 5, when you add a negative 5 and a negative 12, the result is negative 17. And some of you might find it a little bit challenging because you did not take heed when I said that you have to know your directed numbers inside out. This one is a model problem. And I will tell you why it is a model problem as soon as I finish solving it. Let's go. Let's go. That's nice. My intention is that you learn something new every day. Number 9. Oh, okay. No problem. It was a pleasure having you on the live. And of course, we're going to be back tomorrow so you can join again. Okay. Have a good rest of the evening. And yeah, another day could be tomorrow because we have class tomorrow evening at 6 p.m. again. So let's continue. This is a model problem. What are the values that we should use? Good night. Well, I'm going to put in the two x's and you tell me the numbers that should accompany them. These made me look too small for you to be so far away. Let's go. Seven one. All right, so -7, -1. Students, whenever the sum is greater than the product, one of the numbers is 1. So as soon as you see that the product is smaller than the sum, or you say that the sum is larger than the product, anytime the product is smaller than the sum, or I prefer to say anytime the sum is larger than the product, one of the numbers is 1. When the sum is larger than the product, one of the numbers, I see 3, 4, I see 5, -5, -3. Remember now that you're looking at the 8 alone to say that it's a -5 and a -3. You have to look at the product, because when you multiply a -5 by a -3, you do not get a +7. So everything has to be a perfect match. The sum has to match. You have a sum matching there, -5, -3. If I were marking your paper and you put -5, -3, although it is not correct, it is not entirely wrong because you have the sum right. Yeah, so your sum is right. Being a -5 and a -3, the sum is correct. But the product needs to be correct also. Yes. You're welcome. Yes. Right. This is, I don't like when the product is 18. I think that's an awkward number. I don't know why. But we have it right here. The product is -18 and the sum is a +6. Sorry, a +7. You know why I say 6. Alright, let's go. The product is a -18 and the sum is a +7. Yes. -9 and +2. Lovely. Let me write that. X minus 9. X plus 2. I know that individuals are going to be angry with me for this because they said, Mr. James, you just explained to us that the sum, when the two numbers have different signs, the sign of the sum is the same sign as the larger. And that is by no means a new invention. I hope that I'm not stuck on the screen, students. If I'm not stuck on the screen, because I saw a little glitch a while ago. So I hope that I'm not stuck on the screen. All right, so students, do not forget that what? The sum that we have here is comprised of a negative number and a positive number. That's correct. A negative and a positive, that's what they should be. Also, a 9 and a 2, that's also correct. But do not forget that the sum that we have here, the sign of the sum, should be the sign of the larger number. Yes. So I have somebody saying is a positive 9 and a negative 2, and somebody saying is what? A negative 9 and a positive 2. Well, surely it has to be a positive 9 because it has to take the same sign. The sum has to take the same sign as the larger. And that is a spillover from your first rule of manipulating directed numbers. Yes, that's a spillover of your first rule of manipulating directed numbers. What do we say here? So let me say the way that I would and see if that is of any benefit to you. Because you might just look at it and say, negative 40. One is positive, the other is negative, and you arrive at the negative 6, and you have your two numbers, and that's beautiful. But I prefer to say that when we have a negative product, the two numbers have different signs. And when we add numbers that have different signs, we subtract the smaller from the larger. So when the sign here is negative, the sum is a literal difference between the two numbers because they have different signs. So I'm going to say what two numbers multiply to give 40 and the difference between them is 6. They multiply to give 40 and the difference between them is 6. And someone has a 10 and a 4. So I would not put in a sign in there yet. I'll put the X, I will put the 10, and I'll put the 4. And I know that they must have different signs. And I know that since the result is 6, and it's negative, because the result is negative, I know that the sign of the larger has to be negative. And that's a nice way to do it. And here's the same model problem number 12 is another of your model problems. And so here's another of your model problem. So as soon as you see this one, you know the answer already. Let's go. I shouldn't take too long to see the values going up on the screen. Me like that. 10-1. Yeah, 10-1 is very nice, yes. It's 10-1. Because when the sum is greater than the product, one of the numbers is 1. Right? Yes, one of the numbers is 1. But at the same time, students, you cannot neglect your signs. And what I find a little bit intimidating here is that if you just say 10-1, I imagine that you're just saying it early because you should arrive at the answer quickly. But of course, you did not apply your signs, and I'm looking for the signs. And then one says it's a negative 10 and a positive 1. The reason for you to come to the conclusion that it's a negative 10 and a positive 1 is because you are attacking the problem from the wrong end. Yes, you're approaching the problem from the wrong end. What end do you arrive at, do you attack the problem from? The product. The product is a positive 10. Because the product is a positive 10, then the two numbers must have the same sign. Because the only way to arrive at a positive result by multiplying two numbers is if the two numbers have the same sign. So the product is positive, so you know that the two numbers have the same sign. I'm going to write that again. So I'm going to take out the 10 from here and put the 1 over there. Students, whether you are going into education or sports, any weakness that you have will be exploited. Yes. Any weakness that you have will be exploited. And one of the general weakness that individuals have is not demonstrating presence of mind. For example, we give you a problem, which is a model problem, and you should see the answer immediately. But because you see the answer immediately, you do not spend enough time to scrutinize you do not spend enough time to scrutinize the signs. So you do not give too much attention to the signs. Competitors use stuff like that in competition, where they show you an easy hit. Right? They show you an easy hit. And then when you take that easy hit, you get caught. Because what? You did not give consideration to the fielder that is placed specially for the shot that you're about to play. So, of course, the sum is greater than the product, so one of the numbers is 1. So, to conclude that it's 10, 1, excellent also, but the two numbers must have the same sign, and the sum is negative. That means the two numbers must be negative. All right, thank you very much. If I were not paying attention to that one, then I wouldn't realize, oh, you passed that one already. Very nice. So this one is what? A negative 1 with a negative 10. And someone is saying that this one is x minus 7. I'm going to write it a little bit somewhere. X minus 7 with x minus 7, which is equal to x minus 7 all squared. So you're looking out for your perfect square, and there you have it. The two numbers multiply to give 49, and the sum is negative 7. Yes. Yes, they multiply to give a positive 49, and the sum is negative 14. So you arrive at that one in quick succession. So let us take a look at number 14. And of course, this is analogous to number 13 is analogous to number 12, to number 8, to number 3, and to number 1. Right, so you can solve that one easily by analogy, and that is always recommended. All right, your favorite, they multiply to give a negative 32, and when you add them, the result is negative 4. They have a product of negative 32, and they have a sum of negative 4. They have a sum of negative 4 and a product of negative 32. Lovely. So I hope that I'm on and going. Okay. Nice. All right, so we have a -8 and a -4. That's nice. They have a product of -32. Since this product is negative, the two numbers have different signs. Therefore, we are looking for the two numbers that multiply to give 32, and the difference between them is 4. So let's go. The sign is negative, therefore, the numbers have different signs. So of course, we know that numbers are going to have different signs. So we are looking for two numbers that multiply to give 32, and the difference between them is 4. So go S, S. And you can say the difference between the one that we are talking about is what? 8 and 4. We know that they have different signs. Also, we know that what? What else do we know? That because they are of different signs, when we find the difference, the answer will take the same sign as the larger. So, because the sum is negative, the larger number is negative. Like that. And of course, number 15 is analogous. It is a twister also. Number 15. Number 15 is also a twister. So what do we say about that? Apart from nothing. What do we say about that one? Which two numbers? I'm going to say that again. What I'm saying is that you do not have to stick like a slave to what I say, but I'm sure that we have students here will find them to be very useful. All right. Some students start to factorize trinomials from grade 9. Right? Yes. Some students start to factorize trinomials from grade 9. Now, with Richard James Mathematics Resources, and I think that I'm going to start to do that soon, to show you my students of the week. I'm going to start to do that video demonstrating students of the week. And you will realize that I'm going to choose students of the week from grade 7, grade 8. You're not going to get student of the week if you have not passed CXC Mathematics with me. So if I choose a grade 7 student like Courtney Thompson, or a grade 7 student like Joshua Gale, or somebody who was not in grade 7, like Janelle Sampson. She was not in grade 7, but she was 12 years old when she passed the CXC exam. She was in grade 8, but she was 12 when she passed the CXC Mathematics exam. So, I don't put a limit for age on what I am teaching. I learned that early that I should not do that. Because Chu, when Chu was 12 years old, he got a distinction for mathematics, a distinction for English, a distinction for Spanish, and a 2 for French. Right, so as long as you're in high school, there's nothing that I do that is beyond you, because we have students from grade 7 and also students who are 12 years old passing the CXC Mathematics with Richard James Mathematics Resources. But in typical high school, they start to factorize trinomials from grade 9. So, of course, this one, I'm going to say it in my way that I always say it, but students, as a matter of fact, I'm sure that I'm not the only one who approaches stuff like that. So when I say it, it's not unique to me. You have other mathematicians who do it too. So let's say, I'm going to say a -24 tells me that the two numbers have different signs. That means, since they have different signs, we're going to find the difference. So which two numbers have a product of 24 and the difference between them is 10? So they have a product of 24 and the difference between them is 10. That is why I call it a twister, student, because you have a negative 6 times 4 will give you a negative 24. But when you put a negative 6 with a negative 4, you do not get a negative 10, although 6 plus 4 equals 10. So because the signs are different, it has to be a negative 6 with a positive 4 to give you a negative 2. A negative 6 with a positive 4, when you're adding them, the result is going to be what? Negative 2, because you need to subtract the smaller from the larger, and the answer will take the same sign as the larger. So while you're not right, you're not entirely incorrect. Right? And we expect results and answers like this, and that is why by the end of the day tomorrow, I hope that you'll be able to do some twisters. Yes, some nice twisters will be placed on the board for tomorrow. So although 6 4 is 24 and 6 plus 4 equals 10, because of the requirements of the sign, 6 and 4 will not work. So the correct answer will be what? A negative 12 and a positive 2. So negative 12 plus 2 is negative 10. And when we multiply a negative by a positive, we'll get a negative. So this is going to be a negative 24. If we use the 6 and the 4, we can use the 6 and the 4. If we use the 6 and the 4, what will happen? Because they have different signs, and we're going to find the difference when they have different signs, the difference is not going to be negative 10, but negative 2. So that is why 6 4 will not work in this particular case. All right. So I'm going to go immediately, and I'm going to do in one shot, put the next 5 on the board. I cannot find one of my markers. But you know, when I cannot find one of my markers, I have a good number of markers there still. Just one of them is just missing. All right. Which one is another model problem? Did we see? Yes, we said that this one is a model problem. Of course, it's the perfect square. We're not going to be shouting for a perfect square. But I wouldn't call it a model problem, because although the numbers are equal, I don't think that there's anything special about that. So number 16. Number 16, x squared minus 11x minus 60. If it is not minus, I can change it to plus. Yes, it's minus 60. Number 17. 17 is x squared plus 5x minus 66. X squared plus 5x minus 66. 17, 18. A squared plus 2a minus 80. 19. C squared plus 19c plus 60. And last but not least, number 20, t squared minus 4t minus 60. Let's go. Do I have any answer for the first one? I was teaching at a particular institution And the class was on a Sunday morning at 8 a.m. The class was on a Sunday morning at 8 a.m. And I never attend a single class late. And when I got there, almost everyone was there waiting for class. And that was 8 a.m. Yes, that's how it was in the olden days. 20 years ago. Over 20 years ago. 2001. Let me see, 2000, maybe 2001, 2002, maybe 2002, 2003. That in those days. Yeah. And Marcus Garvey learned to read and write in Sunday school. Yeah, you get that one now. Yes, it was at Sunday school that Marcus Garvey learned to read and write. I hope that you're hearing me. They're saying that there's no, I see the sound graph, so I think that you're hearing me. And somebody would have complained nonetheless. Well, you'll tell me specifically what fraction ones I should try. And then I will do them for sure. Yes. So let's go if we have the time. But you know that we are going to go through the tutorials nonetheless. Alright, so let's continue. The two numbers multiply to give a negative 60 and they add to give a negative 11. What are they? No, there's my other marker. I have not figured it out as yet. I have not figured it out as yet, but I'm going to figure it out in a few seconds. Yes, I figured it out by now. Yes, I have figured that one out. Then 60 students. Yes, 15 for it. Thank you very much. Right. Yes, I like that. One say 15 negative 4, one say negative 15 4, the other one say 15 negative 4. Nice. Students, you should not try to be wrong. But if you are wrong, it's not like something bad. It's not anything bad. You just didn't get it right there. Maybe you have a lapse in concentration because you have the 15-4, you have the two different signs, but do not forget that the middle number is the sum and should take the same sign as the larger one. Do not forget that the sum has to take the same sign as the larger one when the signs are different. Do not forget that when the signs are different, the sum has to take the same sign as the larger one. And here's another one, somewhat analogous to the one that you have just done. We have three analogous problems, one behind the other. And as a matter of fact, number 16 to 20, of number 16 to 20, only one is not analogous. (11:6). I like that. Of course, the negative 66 tells us that the two numbers have different signs. Well, I'm going to put in the x with a plus sign and the x with a negative sign. So we know that they have different signs. We know that when we put it in the sign, because the sum is positive, and mark you, this is when the numbers have different signs. The sum is positive, so the larger one will be positive. Did somebody say it's 11:6? Yes, all of you said that it's 11:6. What about this one now? I know that students will jump for joy for this one because they cannot deceive you with this one. 80, oh my. It's a giveaway. So I'm just waiting for a few seconds to see what will happen there with the 80. Yes, I'm just waiting for a few seconds to see what will happen with the 80. Come on, students, you're not going to say that it is 8-2. No, you're not going to say it's 8-2. All right. Now, students, you can, all right, a guess is not wild, right? So a guess is not wild. So if you make a guess, you're making that guess intelligently. Now, when you make a guess, it does not have to be right. But you have to recognize that it is not right, and then you make the adjustment. For example, if I see 80, the first thing number that comes to my head is 10. As soon as I see 80, 10 come to my mind. I'm just thinking 10 of one of the numbers has to be 10. Does the number have to be 10? No, because 16 times 5 is 80. So it does not have to be 10. But I'm hurrying for 10 when I see the 80. So I'm thinking that one of the numbers is 10. And if one is 10, the other one is 8. And of course, the difference is going to be 2, and I'm right. I don't have to be right for taking that, making that guess and taking that approach. I can guess that it's 10 because of the 0. But it does not have to be right. Turns out that it is right on this occasion. More powers to me. Right. Do not miss, student. Do not miss the opportunity to say 10, even if it is wrong. If it is wrong, then you know you have to rethink what you have said. All right, so let's go. Students, why? I'm thinking because I try to see if I can figure out, why 10 2? Because you know that 10 times 2 is 20. All right, so somebody say negative 8. Put that in. A minus 8. The two numbers have different signs, so I'm thinking it's a plus 10 right there. Of course, it's correct, because it has to take the same sign as the larger one when the two numbers have different signs. Now, the only challenge that students have here is with the 60, because 60 has a lot of factors. The factors of 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30, and 60. So it's a lot of factors that 60 has. So that's the only. If you multiply the 10 by the 9, okay, if you add the 10 and the 9, you surely will get the 19. So you're not entirely incorrect. But when you multiply them, you're not going to get 60. And I think that this problem, students, I'm going to always remind you about what? Presence of mind, students. Presence of mind. Presence of mind. The reason why I turn around a second time and look at the board, I'm going to tell you when somebody figured it out. 15-4. Students, remember that we use 15-4 here. So you have to have the thing in your mind, even if it's not like something that you retain for the sake of retaining it. But you could at least remember that, no man, what would it use with 60 a while ago? Would it use with 60, 15-4? 15-4 can work again. Because in this particular case, it's going to be 15 plus 4. So don't miss out on opportunities like those, students. So we're going to have what? C plus, is it C? Yes, it's C. And I said C and write A. All right, let's go. C plus 15 with C plus 4. Nice. And finally, what do we say about that one? Apart from nothing, what do we say about that one? All right, so this is going to be, I'm taking your answer T, minus 10 with t plus 6. Yes, t minus 10 with t plus 6. Nice. Now students, I'm going to continue with your homework, the solution of the problems that are in your homework, but I will go to your favorite, your perfect square and your difference of two squares. And I was just looking on the board to see if I can put those in. Yes, I can. So, let's get with it. Number 1, x squared plus 2x plus 1. X squared plus 2x plus 1. I'm going to write every single one of them. 2 x squared minus 2x plus 1. And of course, the exercise said that what you have there is either a perfect square or a difference of two squares. It's either a perfect square or a difference of two squares. But you know a difference of two squares only has, it says 2. A difference of two squares only has 2 terms. More. So you know the ones that are perfect squares already. 3, 4x squared plus 4x plus 1. Since I find my next marker, I'm going to use it for the rest until I hear a voice say that I should change the markers around again. Number 5, apart from, let me see, yes, number 5. Your favorite coming in now. I'm going to put number 9 right there. If I put number 9 right there, you're right, it's going to be out of the bright light. I know that I left one out. I'm going to go for it and put it on the board also. Let me see if somebody said it. I like that, you know. Yeah. All right. Yes. So I like the way that the student answered that one. That is 1 and 1. All right. All right. Yes, I'm enjoying this one. Yes, that one is really hilarious. Someone said that for the first one is 1 and positive 1. And for the second one is negative 1 with negative 1. Students, what I'm saying is that these expressions that we are doing in this phase, they are either a perfect square or a difference of two squares. And of course, you know the difference of two squares because the difference of two squares contain two square terms. Right, and of course, there's difference between them, meaning that one sign is positive and the other is negative. That's beautiful. So I'm delighted to see the correct answers coming in as if this is a trinomial. Of course it is a trinomial. And you may factorize it like a trinomial. Yes, it is a trinomial and you may factorize it like a trinomial. But I'm saying it's a perfect square. So since it is a perfect square, students, you can do it like this. All squared. Since it's a perfect square. What do you square and the result is x squared? When you square x, you get x squared. X should go there. What do you square to give 1? A 1 will go there because 1 is what you square and the result is 1. Of course, the sum is positive, so that should be a positive 1. So you are correct to say that it is x plus 1, x plus 1. Also, for this one, I saw the students saying, I'm going to take a second look at that. Also, this one, right. Also, for that one, somebody already said it, but because it's a perfect square, I'm saying it's a perfect square already. So since I said that it's a perfect square, you do not need to put it in two brackets. You can just write it as a perfect square. So, what do you square and the result is x squared? X. What do you square and the result is 1? 1. And of course, the sign in the middle is negative. We'll get it like that. So if you know, student, that is a perfect square, then you can write the answer down like I'm doing it now. Why would it, let me see, we have an 8 plus 16 plus 32. What do you think? What do you think? The one that says, do you know how to do vectors? What do you think? You tell me what you think when you say, ask me a question like that. Do you know how to do? You can answer it yourself, you know. You can answer that question yourself if I can do vectors. Yes, this is of course going with the CXC syllabus. But in the olden days, I wouldn't say olden days, during COVID lockdown, although I was going to the CXC syllabus, in the COVID lockdown I had students from the United States and Canada joining. And of course, it did a lot for them in their respective schools. Students, when you do CXC mathematics, you have vectors in 2 dimensions, your regular CSEC. When you go to CAPE, which one are the meeting again? Unit 1. When you go to Unit 1, it is what? Vectors in 3 dimensions. And of course, you have like how you have the equation of a straight line, you have the equation of a plane. When you go to, when you go to the higher level for mathematics, you have for a plane. That's a very nice question, man, if you can do vectors. It's a beautiful question. Just give me a few seconds if I can do vectors. All right. So this book is entitled Transformations, Vectors and Matrices. This book is a part of Richard James Mathematics Resources. Needless to say, I did not download it from the internet. Right? Right, so this is one of the books that I've written for my students. Vectors, matrices, and transformation. Right? And if the ruling people, whether it be the opposition or the governing party, had any use when it pertains to the mathematics resources, I would have had another vectors matrices in it. But that one, maybe just vectors alone, or maybe it's just a module that contains vectors like equation of a circle, vectors, and so on. I would have one advanced level book like this. Right? But they prefer to throw away the resources that will help the students so that the students will get 30% pass in CXC mathematics. So that is why books like these will not come to the fore, because it is in the best interest of both the PNP and the JLP to keep the people down and uneducated and misinformed and disinformed, so that they will be easily exploited. And that is why this book is not highlighted nationally. Part of Richard James Mathematics Resources. You don't see, CXC Mathematics, you don't see anything yet, students. You're just scratching the surface. When I graduated, it's not a graduation, it's just you leave high school. When I left high school, students, I passed 4 levels of mathematics, and this one is the lowest one. So let me give you a little thing about my background. When I left high school, I passed this CXC mathematics, additional mathematics, advanced level mathematics, advanced level further mathematics. I have A for abstract algebra. If somebody tells you that they have A for abstract algebra, don't take him lightly. And my grade for the applied calculus with Harvard University is 97%. And there was something inside of that program by the name of phase plane analysis. And it's not because I couldn't do it, it's just because I couldn't bother. It was in the summer and I was doing a lot of running up and down and going to Kingston and St. Catherine and all over Jamaica. And when it came to the phase plane analysis, I didn't give it any patience or any other, I just skipped over it. And that is why I got 97% for applied algebra with Harvard University. And I am 5 times national mathematics champion. 4 times as a student at Cornwall College, let me make you know right now. And 1 time as a teacher at Cornwall College. So give you an idea who is standing here. I prefer to be simple and act simple. But I've covered quite a bit when it comes to mathematics. Right, of course. My intention is for the students to even excel beyond what I've done. Because I don't know, I know that one of my students was in line, I know that he got it, first class honors for actuarial science. And you know that is not like a common thing to get first class honors in actuarial science at the University of the West Indies. And the person who was next behind him for first class honors was also one of my students, Bianca Jones. The other one was Adolex Grant. You quite likely will see them coming up when I'm doing Students of the Week. Yes. So let's continue with this and let us finish up. Dear perfect square, what do you square in order to give 4x squared? That's 2x. And what do you square to give 1 is 1. And of course, the sign is positive. Any other perfect square? Yes, we have 2 more. Number square and number 5. What do you square to give 9x squared? And what do you square to give 1? Three x. So when we square 3x, we get 9x squared. I see the answer for the next one already. And then of course, the middle sign is a plus and it's a 1 right there. And somebody gave me this one already. I hope, 5x squared plus 5x, plus 2 all squared. So I saw that also. Right there, 5 with 2. We are and. Okay. Is there any more? Number 6. What do we say for this one? What do we square to give x squared? And what do we square to give 4? And on this occasion, the sign is negative for that one. And of course, I'm at your favorite, difference of 2 squares. Difference of 2 squares. What are you going to say about the difference of 2 squares apart from nothing? So this one will be what? 2x minus 1, 2x plus 1. That's your difference of 2 squares factorization. And of course, you did this one in class or in homework. Apart from here. I think you did something like that in your class. Two x minus 1, 2x plus 1. I see that there. So I'm giving you some time to give me the one for this. A squared minus b squared. That's your favorite. A squared minus b squared. That's your favorite. That's your very best. A minus b. Of course it's correct. A plus b. Yes. So for a difference of 2 squares, you're going to see, students, you're going to see a lot of other visuals on the difference of 2 squares during this week. Because I don't remember how many I have. But it's going to be quite a bit. Right? So you're going to, maybe the entire week this week for difference of 2 squares. And of course, you're going to go to trinomial. But the trinomials that we did, I don't have a lot of videos on that. I have to go and give you the Vimeo link. Maybe you'll find a lot of that kind there. So let's continue. What do you square to give a squared? What do you square to give b squared? That is for the difference of 2 squared. So one is a and the other is b. So a, I'm going to do the one that you did. You put the a minus b first and then the a plus b after. And of course, it doesn't matter which one you put first. Right. I usually put the a plus b first, but I think that the a minus b is better. Yes. I usually put the plus 1 first. That's what I do, put the plus 1 first. But you put the minus 1 first, but I think that putting the negative 1 first is better. And let me see if anybody can figure out why I think that putting the negative 1 first is better. Yes, somebody gave me the answer for this. And they put the negative 1 first also. 1 minus x. And the other one is 1 plus x. You put the negative 1 first. And then we have the last one in that section. And of course, I'm taking a look at it. 11x minus 1, and I'm sure to see the next one going up right after that. 11x plus 1. Students, I will accept that in a live chat, just to put 11 plus 1, 11 minus 1. But in actuality, for an examination, you need to put the x. And that's all there is to it. And I'm looking in your tutorial. Yes, one of my marker is on the ground. I'm looking inside of your tutorial to get some more, have some more fun. No, that number 1 is too horrible. I'm not going to take a look at that one. All right. Ooh, no. All right. No, students. We're at the end of your... No, we're not at the end of the tutorial, please. We're not at the end of the tutorial. So don't want to think that. No, don't think that. Now, we have at least half an hour left. But I think that if I do these, it will take me a little bit over, although I'm not doing all of them. So I'm going to leave some for you to do. So I'm going to be doing the even numbers. Yeah, I think that I'm going to be doing the even numbers because it's not homework. Do the even numbers. Let me see. Do you have some with some very interesting result? I think that they are present in the odd numbers. I guess there's a lovely mix. One of these days you'll ask me to do something else and I will do it. But for now, I'm going to find another tutorial on paper and use it. This one has a pale page. Yeah, this one is brighter. I'm going to make a decision in the end. And you will do the rest. All right, so let's go. All right. So, students, I'm going over into your tutorial book. Tutorial 1. This is for the YouTubers and this is for the TikTokers. All right. So I'm going over. Yes, students, I'm going over I'm going to take substitution. I think I might go over a little bit, but I hope that you'll give me a few more minutes. So I'm going to go to do the even numbers. Let's go. So I'll begin with number 2, and it says that x is equal to y is equal to -5 and z is equal to 3. So we should find A. A is x minus 2y. X minus 2y. Now students, what I suggest that when you're doing substitution is that you write a template that is similar to the expression that you have there. So you have x minus 2y, so you should have what? Something minus 2 times something. That's what you should do. Write a template and leave the space. So the template has the potential to reduce error by trapping the negative sign. Yes, it has the potential to reduce errors by trapping the negative sign. So x is 2 and y is -5. And there you go. 2, then negative times negative is positive. And then your result is just 12. And that's interesting. B, xz squared. Now students, when you are solving a problem, sometimes you should ask yourself the question, why would they give us a problem like this? So xz squared is what? Something squared. Right, so you do a template that looks like the expression. Then you put your values in. 2 for x and 3 for z. 2 for x and 3 for z. Why would they do that? They do that with the intention to determine if you know that you need to square before you multiply by 2. So you should square before you multiply by 2. They want to know if you know that. And that is the intent and purposes of doing this one. So there you're going to have what? 2 to be multiplied by 9. Which is equal to 18. Because what? 3 squared is 9. But some students will do what? 2 times 3, 6. And then square the 6 to give 36. Which is wrong. So you should square first before you multiply by 2. And they are testing if you know that you should do that. Nice. We have a C there. Nice. C? Oh my. C is supposed to be a little bit wide on the board. So C, for C, what do we have? And I hope that we're not too cramped for space. 7x plus 2z over y. 7x plus 2z over y, which is equal to 7 something plus 2 something over something. Right. X is 2, z is 3, y is -5. Now students, 2 takes longer than 5. Good evening. I don't teach particularly the grade 8 syllabus, but I teach a lot of stuff that are in the grade. Yes, I teach a lot of stuff that are inside the grade 8 syllabus. I'm teaching the entire CXC syllabus this year. And do not forget that we have a lot of grade 7 and grade 8 students who pass the CXC Mathematics exam. And my first student of the week is going to be an 8th grade student. And quite likely, the next one will be a grade 7 student. Quite likely, but not necessarily. So when I start to post those videos, I think that I should do that, start to put the templates for them, because parents, everyone needs to know that students pass examination early. So I'm not limiting anyone to any material that I'm presenting. Surely not now. Now what do we have there? As I said, 2 takes longer than 5. It is better to take 5 extra seconds to look at the question than 2 extra minutes to solve it. Because you can see this, 7 times 2, that's 14. 2 times 3, that's 6. 14 plus 6 is 20. You divide 20 by a negative 5, you get a negative 4. So let's give you what? 14 plus 6 over negative 5. And the result, the final answer is negative 4. Because 20 is going to be there. Students, I'm not doing every one for you. I'm doing the even numbers. You will learn if you put your mind to it. The concepts are done in a nice way, so you will not have too much difficulty. B is equal to negative 2, and C is equal to 3. And number 4 says A squared minus BC over B plus C. And of course, what are you going to do with that? You're going to put up your template. Yes, I do advanced algebra. You don't remember that I got A for abstract algebra? Yes. Yeah. And let me tell you somebody who got it the same time with me, another young man by the name of Andrew Wint. But don't say Andrew Wint got A for abstract algebra. Andrew Wint got A for everything. That's how smart that one was. He attended Commonwealth College with me, and we attended the university together. Him get A for everything, including abstract algebra. All right. So let us continue. What do? We do a template. So we have what? Something squared minus something times something all over something plus something. All right. So what do we have? A is 4. When you are putting in the figure for B, you put it in all occurrences of B. So B is negative 2. So you're going to put a negative 2 here and a negative 2 there. And then of course C is 3, so you're going to put a 3 here and you're going to put a 3 there. Now students, as I said before, 2 takes longer than 5. So this one is a bit short. Why? Because you'll see that you have a negative 2 here plus 3. Negative 2 plus 3 is 1. So because the denominator is going to be 1, then the answer is going to be the numerator alone. Because anything divided by 1 is that same thing. So let's go. 4 squared, 16. Negative times negative is positive. And 2 3s, 6. So the answer for that is 22. Why 22 alone? Do not forget that we will be dividing by 1. Because negative 2 plus 3 is 1. And any number divided by 1 is that same number, 6. negative 2. N is equal to negative 3. And M is equal to 4. M is equal to 4. So what do we say now? M plus, I'm going to put it a little bit wider. M plus NL over N minus M is equal to, of course, you're going to write your template. Something plus something, something, all over something minus something. So what do we say? Of course, you're going to put in all occurrences of M first. So if you have an M here and an M here, you know a 4 goes there and a 4 goes there. And what else? N is negative 3. So a negative 3 goes here and a negative 3 goes here. Students, pay special attention to what I'm doing, because I might make Camille of one of these problems. A negative 2 goes there because L is negative 2. So this is equal to 4 plus negative times negative is positive, all over, whenever we add numbers that have the same sign, we add the values and the answer will take the same sign as the numbers that we have added. So this one, a negative 3 with a negative 4 will give you a negative 7. And that will give you 10 over, I'm going to write it with equal, equals 10 over negative 7. Students, there are three correct ways to write that answer. Sorry, yes, 3 correct ways. So 10 over negative 7. Now students, do not leave your answer with a negative denominator. Yes, thank you very much. Do not leave your answer with a negative denominator. So this can be written, all these are equal. Negative 10 over 7, negative 10 over 7, like that, the negative of the fraction, and then 10 over negative 7. All of those are equal. But this one is not acceptable. Well, if you write it like that, I think you'll get it correct, they'll mark it correct in the examination. But do not leave a negative in the denominator. You can write it as any one of these because they are all equal. Choose to write it as a negative 10 over 7, like that. I'm going to look where the glare is. So I will move merrily to number 8. Yes, I like this one. I was waiting forever for one that looks like this. And of course, like number 10 also. So I think that I'm going to put it down here. Number 8. So I can put number 8 right here. Number 8, yes. L is equal to negative 2, m is equal to 3, and n is equal to 7. So what we're going to find is Lm. I'm going to write it because it seems as if it's going to be wide, at least initially. So we're going to have Lm. So we're going to have Lm, open bracket, m minus n. M minus n. What is that equal to? Something times something. Then, when you have the normal brackets, you put square brackets because you're going to put other brackets inside there. Something minus something. Like that. Right. So where you have brackets, you could put the square brackets because you're going to have the template, and the template will contain those parentheses. So let's go. The first thing you put in is this L, which is negative 2. Then M is 3, so you put a 3 here and a 3 there. And of course, N is the only one left, and that's a 7. All right. This is by no means, I think that the difficulty that the students will have with a problem like that, because you realize that not so sophisticated. So the difficulty that a student will have with that problem is that the student might have some sign discrepancy. I don't think that it goes much beyond that. Right? And somebody says something about 24, and I think that the person is right. Right, so I cannot get it wrong again because somebody gave me the correct answer already. So this one will be negative 2 times 3, so that's a negative 6 will go there. And then the bracket, and you have 3 minus 7 is negative 4. So you have to be keen on your directed numbers in order to get that right. And take my advice and include the template, because the inclusion of the template no students, this is the substitution. The substitution was not taught in last class. Of course, you know that we have it in our tutorial. There are some things in the tutorial that I don't put in instructional class, like substitution. You don't need an entire class instructing you how to make substitutions. And so that is why I don't put that in our regular class. And then you're going to have simplifying expression. And we're going to do that in tutorial, but we're not going to do it in a regular class either. Stuff that require serious instruction, like what we're going to be doing tomorrow, that will go in your instructional class. Yes, and tomorrow is an instructional class, so those will go inside there. So substitution, you do this from, as a matter of fact, it is also present in the PEP syllabus. So I'm going to go merrily to number 10. Where am I looking? Yes, number 10. Yes, for number 10, A, yeah, I like that. For number 10, A is equal to 4. B is equal to negative 2. And I hope that we have a C there. Is equal to 3. Lovely. And the expressions for number 10 says A minus B over BC. I hope that's what I have here, yes. So So of course, something, and of course for the brackets that are there, we put square brackets, and it is something minus something all over something times something. This looks kind of wide, but that's fine. So A will go in first. Two occurrences of A, a 4 and a 4. B, two occurrences of B, a negative 2 and a negative 2. And I think it's only one occurrence of C, which is a 3. Alright, no doubt we will have a fraction there. I think that there's some cancellation. Yes, it looks like we're going to have some cancellation right there. Because I'm taking a broad look at it, student. Because I'm taking a broad look at it, I see that we're going to have 4 plus 2, which is going to give us 6. And then this is going to give 6. So this will cancel with this, and we have a 4. It's only the sign of it that will make the difference. Will make the difference. I know what is going to make the difference. So only the sign will make a difference there. You can already see that the result is going to be 4. Yes, students, it is good if you take a broad look. Because if you take a broad look at it, you can see what the answer is going to be like already. If not what the answer is going to be, what it is going to be like. So, we can see that this is a 6 and this is a 6, so we'll cancel it. So I'm thinking that the answer will be a negative 4. Let's go. So that's going to be a 4 right there. Then you have a 4 minus negative 2. Negative with the negative. Remember this from rule 3? That when we have consecutive signs, yes, the answer is going up already. Lovely. Thank you very much. Yes, so when you do things like that, I cannot get it wrong because you have given me the correct answer already, you know. So it means that I cannot do anything wrong after that. So we have what? A 4, and of course 4 minus negative 2. We have this in rule 3 when we are doing directed numbers. So we're going to have what? 4 plus 2, and that is going to give us a 6 there. And then that is going to be over a negative 6. So we are sure that the answer is going to be negative, and it simplifies down to 4 because the 6's will cancel. So your answer will be a negative 4. Number 12. Number 12, we are going merrily along with our tutorial. Sorry about that. And I'm at number 12. I love number 12. There's only one thing. It has 2 parts and it's just down here. So I'm sure that down here will be exhausted. No problem. P is equal to 5. P is equal to 5. Q is equal to 0. As soon as you see 0, I'm not going to tell you what to expect. But as soon as I see 0, I expect something. So things don't pass my eye without such scrutiny that I'm going to predict some of the things that I can predict some of the things that they will say. Not that my prediction will be correct, but I'm thinking that it's going to be correct on this occasion. So the first one is 4p minus qr. Roman 1. For Roman 1 we have 4p minus qr. 4p minus qr. And I think 4p minus qr, I think that I'm taking the other marker. I can continue with this one, and that is equal to what? 4 something minus something times something. 4p minus qr. P is 5, goes there. P is 5, goes there. Q is 0, goes there. And it does not matter what r is, but it is negative 3. So students, as soon as you see that one of these is multiplied by 0, that one will fall to 0, and 4 5 20. So this is equal to 20. Right? And you're having a lot of fun already, because you figure that one out in such a short space. Roman 2. What do we say about Roman 2? Don't tell me nothing. 2r to the power of 3. 2r to the power of 3. G. 2r to the power of 3 is equal to what? 2 times something to the power of 3. I'm looking again to see if I have the right thing. 2r to the power of 3, yes. So r is a negative 3. My prediction is wrong, students. Yes, my prediction is wrong. But that one is not far-fetched. Now, students, I hope that you can figure out why they put that there. Surely, you should raise it to the power of 3 before multiplying by 2. Yes, you're going to raise that to the power of 3 before multiplying by 2. And the negative 3 to the power of 3, students, there are so many things that you have learned already that will give you the correct answer. I see the correct answer on the board already. And negative 54 is correct. And I see some people put in 27. You're putting in 27 because you're doing it in reference to the negative 3 cube. But what you need to understand that is when you cube negative 3, you're going to have negative 3 times negative 3 times negative 3. That means you're going to have, remember that rule that we have? We have a rule saying that whenever we multiply numbers with their signs, we count the number of negative signs, and if the number of negative signs is odd, the answer is going to be negative. So when you have a negative 3 times a negative 3 times a negative 3, because that's what is negative 3 cubed, that's what it is. 3 occurrences of negative 3 multiplying. Right. 3 occurrences of negative 3 multiplying. So you're going to have 3 negative signs there. So the answer is going to be a negative 27. Negative 27. Therefore, the result is going to be negative 54. This is equal to negative 54. All right, so I'm going to erase all of this. I'm hoping that the tutorial will finish in good nick because we have up to number 12. I think we have 14 and 16 left. And then that will be the end of it. Because I'm only doing the even numbers. And then it is up to you to do the others. And then you will have a wonderful time. Not only learning, but getting sharp for the examination. So number 14, yeah, that's my favorite. Watch me now, students. Number 14. Number 14, I'm going to put the values up there first. M is equal to 20 and N is equal to 48. Now students, in the olden days, we imagine that when we get a problem with this level of sophistry, that it is easy. Yes. Yes, that it is easy. We think that it is easy. Why do we think that it's easy? Because we are just thinking that we should get a rounded figure. And if not a rounded figure, if a fraction is going to be a simplified fraction for our answer. Let us be proven wrong. But let's not attempt to solve the problem imagining that it is anything difficult. All right, so let's go. So, what are we going to have? That is going to be, do I write it a little bit closer? Let it stay. So we're going to write it like this then. This is equal to the square root of 5 something over 12 something. So the first one is 5 times what? M is 20. So M is 20. In the space of M, we put 20. Nice. And in the place of N, we put 48. Nice. Now students, you're going to see that very quickly, that 5 times 20 is 100. And of course, you know that we can find the square root of 100 quite easily. Of course, you know the square root of 100 already. But the square root of 12 times 48 should be a simple result also. So what you could do with it, 12 times 48, you could write it in double factors. Because if you have the square root of 4 times 4, then the result of that is 4. And if you have the square root of 7 times 7, then the result is 7. And you have the square root, so if the number is so sophisticated, 138 times 138, then the result is 138. So if we can double the factors here, then we are through. But of course, you can see that we don't even have to double them, because if we write 48, we're going to write 48 as 12 times 4. So we're going to write, the 12 goes back, the 48 is 12 times 4. 12 times 4. That's the 48. So when you're going to write that again, you're not going to write it with the square root sign, because the square root of 100 is 10. The square root of 12 times 12 is 12. And you know the square root of 4 is 2. And you can simplify that. 2 into 2, 1, and 2 into 10 is 5. So that is just simple 5 12s. And that's your final answer. So we are right then. We are thinking that it should turn out to be a simple fraction. It should turn out to be what we call is rational. Oh yeah, when you multiply this, you will get 576. I have no doubt. Then you take the square root of 576 by using a calculator. But I am not using a calculator. So I have to devise means to get the answer without using a calculator. So instead of going big, I go small. So you can go to the 576, which is a large number, because you imagine that you would use the calculator to find the square root. No, but I don't have that luxury. So what I do is, instead of going large, I go small. So instead of taking the 48 and going big with the 12, I take the 48 and I write it as 12 times 4. So of course, the square root of 100 is 10. The square root of 12 times 12 is 12. And the square root of 4 is 2. And then we simplify like that. Now students, as it pertains to the square root, later on, yes, as it pertains to the square root, later on, we'll discuss quite a bit of stuff about the square root. Because you have to understand that the square root of a number occurs in pairs. So for every number that has a square root, there are 2 of them. So if somebody asks you the square root of 4 and you say 2, then if you're doing school challenge quiz, you will not get that as the correct answer. No, they will say that it's not right. Because 4 has 2 square roots. One a positive 2 and the other a negative 2. But for the intents and purposes of this problem, we're just working with the positive square root only. So we're just taking the positive square root only. No, I was just wishing that after number 14, I'll just finish up with number 16 and everybody will just have a jolly time. But I have number 16 that I'm going to put. I'm looking at the board where the light is. So I can put number 16 here. Yes, almost on the same level. Let me see what number 16 says. So put number 16 right here. It says that given that a squared minus b squared is equal to 96 and a plus b is equal to 16. A plus b is equal to 16. Find the value of a minus b. Find the value of a minus b. Find the value of a minus b. Now students, I'm very happy that this very expression that we have here was on the board not too long ago. Alright, so let me write it down. Let's go. A squared minus b squared is equal to 96. I'm going to put it wide. Is equal to 96. Yes. A squared minus b squared. I'm going to write the a brighter. A squared minus b squared is equal to 96. Student, is there anybody who knows something about a squared minus b squared that we might find to be useful right there? Tell me. I'm very happy for that. I'm very happy that you are enjoying the class. Correct. Yes, I'm really very delighted to know that. Yes. Sir, I got a minus b is equal to 6. That's nice. I don't get the answer yet. So I'm sure, I'm hoping that your answer is correct so that I can copy from you. A minus b is equal to 6. All right, students, you know, because they're saying that a plus b is 16. And they're saying a squared minus b squared is 96. And you know about a squared minus b squared. You know that it is at least a difference of 2 squares. So you have a difference of 2 squares. You have what? When you factorize this, you get what? A plus b, a minus b. And that is equal to 96. Then, a plus b is 16. So a plus b is equal to 16, and this is a plus b. So that one is equal to 16, and that one is a minus b is equal to 96. So all you need to do now, you're going to eliminate this 16 by dividing by 16 so that you can find what a minus b is equal to. So 16 a minus b is equal to 96. So you're going to eliminate that 16 by dividing by 16, and you'll do the same on the other side. So these 16 will cancel each other. You'll have a minus b, and I hope that 96 divided by 16 is 6. I'm hoping that, because somebody said that's what the answer is. All right. Yeah. All right. So, number 18. I'm not writing it here. I'm going to write it all over here. Yes, I'm going to write it over there. So what do I say apart from nothing? Number 18. Number 18. I think that they're going to expect us to exercise a little bit more common sense, but let's see. 4p squared minus 4q squared is equal to 2r. P plus q is equal to r. P plus q is equal to r. P plus q is equal to r. Now students, this is 2r. Let me cause it to look more like a 2. 2r, right. P plus q is equal to r. And they want us to show that. I'm going to write it out then. Show that what? Show that P minus Q is equal to a half. Nice. Let me see if there's any twist to it. I guess there's a twist to this problem, but of course, you should not have too much of a difficulty with it. Now, let me go back to this now. 4p squared minus 4q squared. Students, I am sure that you are going to see that that's a difference of 2 squares right there. Right? So that's a difference of 2 squares. And you know that if you factorize that, because students know their difference of 2 squares, they know that they will have what? 2p plus 2q, 2p minus 2q. That's a difference of 2 squares. It can be correctly factorized to be this. But you should not factorize an expression like this, especially when it is like that. Why? Because in the terms that we have here, there's a common factor of 4. Right. So in the terms that we have there, we have a common factor of 4. Yes, there's a common factor of 4. So you should take out the common factor before proceeding to factorize. So please take out the correct factor of 4. So instead of doing this, this is what you should have done. Of course, it is a difference of 2 squares. Of course, you may factorize it in the way that we have just done. It is more appropriate to factorize it like that. P squared minus Q squared. Then, keeping the 4 right there, you have what now? P plus Q with P minus Q. And then this is said to be equal to what? 2r. So this is equal to 2r and P plus Q is equal to r. So you need to show that P minus Q is equal to a half. That might seem to be quite a bit to keep in your mind. Don't put all of it in your mind then. Do it step by step. Do it one at a time. So let's go. First of all, let me write it the other way around. I'm going to write this. Because this is what we have, and they say it is 2r. But this should be most appropriately written like this. Because they are depending on you not only to see that this is this is a difference of 2 squares, but they are also depending on you to recognize that there is a common factor of 4 that you should take out before factorizing the difference of 2 squares. So we'll have this then. 4 P plus Q, P minus Q, which is the same thing as 4p squared minus 4q squared, which they say that is 2r. So they say that that is 2r. Additionally, they say that p plus q is equal to r. So we're going to have 4, and then p plus q is r, and then we have p minus q, and that is, all of that is 2r. So in order to find what p minus q is, we have to eliminate. In order to find what p minus q is, we have to eliminate this 4r that we are multiplying by. So we're going to divide by 4r there, and we're going to divide by 4r over here. So the 4r will cancel, and we have p minus q is equal to, the r's will cancel, and 2 over 4 may be simplified to a half. So p minus q is equal to a half. No, students, they will not twist us around. Just do it step by step. Just put in the values that you have. Of course, you have to be able to factorize the difference of two squares in order to solve this problem. And of course, although it is necessary to be able to factorize the difference of two squares, it is not sufficient. And I'm using a terminology that I used earlier on, necessary and sufficient. So although it is necessary to be able to factorize the difference of two squares, it is not sufficient. Additionally, you need to be aware that there's a common factor of 4 that you should really take out before doing any other factorization. Students, no matter what expression is given to you, and say factorize, no matter if it's a sophisticated trinomial or a simple trinomial like the ones we did today, or your difference of two square or your perfect square, and you can factorize and you can factorize, even if it is something that you're going to be factorizing by grouping. Students, make sure that if there's a common factor, that you see that first and take it out. That is how CXC expects you to operate, because according to the examiners and CXC, your factorization has to be complete. That is what the CXC examiners say. Now, students all, believe me, you all get me going with all of your responses. Thank you. Thank you very much. Yes, so thank you for responding and responding promptly in a timely manner, that when I ask a question, say I couldn't work it out, somebody in the class can work it out. Right. And there is a correct answer given to me. So by some other means, I'll be able to get the correct answer because I know what the correct answer is already. So, of course, the whole experience this evening was great. We did our early part of the trinomials. We did the difference of two squares, the perfect square, and we did substitution tutorial. And so we are making some inroads into our tutorials, and we are making some inroads into our algebra book. Now, students, we're going to have a holiday weekend coming up, right? I don't want to say anything about it yet, you know. I want to wait until tomorrow. Okay, so I hope that the students will have completed. Oh, for this is a continuation of the substitution. So this is a continuation of the substitution, but for the substitution it contains some other algebraic stuff like the perfect square, the difference of two squares, and so on. But it is still the substitution that we are doing. And do not forget that we are not going to be doing an instructional class on substitution, because I think that the tutorial is sufficient. And I'm sure that you will conclude that it is sufficient also, that we do not have to do an instructional class on substitution. All right. No, I didn't teach substitution. I'm just doing a tutorial on it because I'm sure that the tutorial is enough. No, we'll have class tomorrow evening. So tomorrow evening we'll discuss that. And students, I am sure that we have a lot of students here who might be interested in the resources. Right, I think that I'll discuss that tomorrow afternoon also. But students, for everything that we do, we have instructional manuals. This is just one of them. The algebra one is right beside me. I have an algebra here. So we have the algebra. This is the one that we are using, the algebra. And this is the transformation matrices and vector that I mentioned earlier on. And of course, we have functions part one nearby. So we have a lot of instructional manual with everything that we intend to teach this year and every other year. And of course, we have your tutorials, as you know, because I was just solving the problems from the tutorials for you to practice every day, or as often as you imagine, or as often as necessary. All right. Okay. So we'll discuss other stuff tomorrow. But for this evening, thank you very much for your contribution. Thank you very much for inviting others. Thank you very much for your kind comments. Thank you very much for sharing the live. And for the new followers of Richard James Mathematics Resources, welcome and thank you for joining. And when you see the hands go up, then you know that the class is at an end. And you can send me a message request if there's anything else that you need to say. But there are quite a few other things that I'm going to put in place, like your Vimeo link and so on. So until tomorrow, because it's just another day, it's just a few hours away, that you are already enrolled in the class. It's just that you might not have the resources. And of course, I'll discuss something about the resources tomorrow afternoon, or tomorrow evening from between 6 and 8. All right, so the class, I'm doing this for anybody who wants to join on TikTok. You don't have to pay. Because I'm not doing any face-to-face class because of the workload that I have otherwise from this class. I have a lot of other stuff to do. Yeah, so my workload is very, very heavy, and that is why I do the class like this. You're welcome. So, when the hands go up. So, before I take them down, yes. Thank you very much. Have a good night's rest and have a good rest of the night. And see you tomorrow. So for now, it is goodbye.